This is the Soyuz spacecraft, used by Russia for more than 50 years now. It's considered to be the most reliable spacecraft ever built. In this video, we'll take a look at the different parts and what it looks like on the inside. And then we'll see how it docks to the International Space Station. Also, I want to say thanks to astronauts Chris Cassidy and Scott Kelly for their help with this video. They've each flown on the Soyuz twice, so it was great to get their feedback as I planned this animation. The Soyuz is a Russian spacecraft that can fit up to 3 astronauts or cosmonauts inside. The word cosmonaut means a Russian astronaut. The Soyuz is currently used to take crews of cosmonauts and astronauts to and from the International Space Station, or ISS. Astronauts from countries all over the world have flown on the Soyuz. When the American Space Shuttle retired in 2011, the Soyuz spacecraft became the only way to take crews to and from the International Space Station. This lasted for almost 10 years. Then, during the year 2020, the United States started launching astronauts on the SpaceX Crew Dragon. Nonetheless, the Soyuz still remains essential to staffing and maintaining the International Space Station. Each Soyuz spacecraft can be used only once. They'll build a brand new one for each mission in space. The Soyuz is operated by the Russian space agency Roscosmos. This is similar to NASA, but for the Russians. The Soyuz spacecraft was originally designed during the space race of the 1960s. The US and Russia were in competition to be the first country to land a man on the moon. During this time, the United States developed the Apollo spacecraft. Even though the Soyuz never had the chance to be used for a moon landing, it was soon after repurposed for missions in Earth orbit. It became a transport vehicle to many space stations over the years. The Russian Salyut space stations, there were 7 of these, the Russian Mir space station, and now the International Space Station. The word Soyuz is a Russian word. This is how it looks in the English language, and this is how it looks in the Russian language. Soyuz. In fact, you can see these Russian letters on the side of the spacecraft. The word Soyuz means union, as in the joining or docking of 2 spacecrafts. Early Soyuz missions practiced docking in space, and it wasn't easy at first. There was even a joint mission with NASA and the United States to dock with the Apollo spacecraft. This was called the Apollo-Soyuz Test Project. It was the first manned collaboration between 2 countries in space. The Apollo spacecraft hasn't been used since 1975. The Soyuz, on the other hand, is still in use today. Each one of these lines represents a flight of the Soyuz spacecraft with a crew on board. This is about 150 flights in total over the last half a century. The Soyuz spacecraft has had a lot of improvements since the 1960s, but the overall appearance of the spacecraft hasn't changed very much. Let's take a look at the Soyuz versions over the years. Starting in 1967, we have the Soyuz 7K OK. This was considered the original Soyuz. The 7K referred to lunar missions, and the OK is Russian for orbital ship. This version was all about practicing techniques that would be required to land on the moon. It had 3 seats, but the crew did not wear spacesuits. Then we have the Soyuz 7KT. The T is for transport. There were no solar panels, just 2 long antennas. It had only 2 seats inside, but this time the crew could wear spacesuits. Soyuz T. This one had solar panels again, and it could now fit a crew of 3. Then comes the Soyuz TM, for Transport Modified. This had an improved docking system called cores at the front of the spacecraft. Soyuz TMA, which stands for Transport Modified Anthropometric. This version allowed more flexibility for taller or shorter crew members to ride on the Soyuz. Soyuz TMA-M, the last M stands for modernized. This had an upgrade to the computers on board and reduced unnecessary weight. The latest version is the Soyuz MS for modernized system. This had improvements to the communication and navigation systems. There's also the Progress spacecraft, which is based off of the Soyuz spacecraft. However, Progress only carries cargo and supplies to the station. It does not carry a crew inside. Over the years, Soyuz and Progress have docked with many Russian space stations, and now they both dock to the ISS on a regular basis. Let's take a look at the most current version, the Soyuz MS, though a lot of this will be very similar for previous Soyuz versions. The outside of the spacecraft is covered with several layers of fabric that provides thermal insulation. This keeps the Soyuz from getting too hot or too cold on the inside. The docking mechanism is in the front. We'll learn more about this later in the video. The two antennas for the core's docking system, the blister window to look out in front of the spacecraft, a docking camera, and an LED lighting system. This is the periscope for the crew to look outside. On the top, there's a satellite communications antenna, the solar panels to generate power for the ship, thrusters on the side and in the back. The main engine is right in the middle. This cover will be opened right before it's used. The Soyuz is made of 3 separate pieces or modules: the orbital module, the descent module, and the service module. The first 2 modules are pressurized, which means there's air to breathe on the inside. Let's take a closer look at each module. The descent module is like the command center. It has 3 seats that are custom molded to each cosmonaut or astronaut, and as you can see, there is not a lot of room inside. Behind their seats is the life support systems, which includes carbon dioxide removal and oxygen tanks. The white bags above their head is survival gear that they could use if they needed to after they landed back on Earth. The instrument panel is here with lots of controls for the spacecraft. In the center, you can look through here to see through the periscope. There's also small windows on each side for the crew to look outside. There's a hatch that can be opened that leads to the orbital module. This is the living area when they are in space. Sometimes they call it the habitation module. They store equipment, eat meals, and there's even a toilet in here. But these aren't like the toilets you'd find here on Earth. There's a side hatch that will be used to enter the vehicle on the launch pad. It's usually not used when in space. The docking hatch is in the front and will be opened once docked to the station. In the very back we have the service module, sometimes called the instrument module or the propulsion module. The service module contains the truss structure, fuel tanks, oxygen tanks, and extra batteries. On the outside of the spacecraft, you can see where the electrical connections are made between the different modules. The only part that returns back to Earth is the descent module. The other parts will burn up as they re-enter the Earth's atmosphere at the end of the mission. To get the Soyuz spacecraft into space, it is launched inside of a massive rocket, which is called the Soyuz rocket. The entire launch takes just under 9 minutes. To learn more, you can watch my animation all about the Soyuz launch. After the launch, the Soyuz is orbiting at about 240 kilometers. The ISS is orbiting at a height of about 400 kilometers. This next part is called rendezvous and docking. This is where the Soyuz will catch up with and attach to the ISS. When the Soyuz launches, it needs to do it at the right orbital inclination. This is the angle that you are in relation to the Earth's equator. So an orbital inclination of 0 degrees would be orbiting right along the equator, but an orbital inclination of 90 degrees would be orbiting right above the poles. The ISS orbits at an inclination of 51.6 degrees. The Soyuz will need to match this. The launch also needs to be timed just after the ISS passes over the launch site in Kazakhstan. In order to show this a little better, I'm going to animate this out of scale so we can see the different orbits. Earlier Soyuz spacecraft took about 2 days for rendezvous and docking, but starting around 2013, most Soyuz spacecraft can dock with the ISS in only about 6 hours from the time that they launch. That's about 4 complete orbits around the Earth. Initially, the Soyuz will be in a lower orbit than the ISS. What we need to do is raise the height of the Soyuz orbit so that it matches the ISS orbit. But it takes a few steps to get there. We need to do a maneuver which involves 2 engine burns, only lasting a few minutes each. We have our orbit here, the Soyuz is going around in a circle. Now we do the first engine burn. It turns out this will stretch the orbit on the other side, so now we're going around in the shape of an ellipse. 45 minutes later, the Soyuz will reach the highest point, which is called the apogee. Notice how this is closer to the ISS orbit. The second engine burn happens here. This will now stretch the orbit on the other side. Now the orbit turns back into a circle, but this time it's at a higher orbit than we had before. We're now closer to the ISS. This process of using two engine burns to raise the height of the orbit is called a Hohmann transfer. So we start off on the insertion orbit, first engine burn, and then we're on the transfer orbit, and then the second engine burn, and we're on the phasing orbit. The Hohmann transfer will need to be done more than once to reach the height of the ISS. Approaching the ISS can be dangerous. The last thing you'd want is to approach the station too quickly and cause a collision. However, this whole process is automated by the core's docking system. If all goes well, the crew won't have to do much. This part of the ISS is called the Russian orbital segment. The Soyuz will arrive at one of these docking ports. Some of these will be taken out by other spacecraft such as Progress or another Soyuz. And yes, Soyuz missions overlap, which means at times there will be two of them attached to the station. The United States orbital segment also has some docking ports, but these are incompatible with the Russian docking system. This Russian docking system is called SSVP, which is an acronym for a Russian phrase which in English means System for Docking and Internal Transfer. The docking mechanism consists of two parts. On the front of the Soyuz, you'll find what's called the probe. And then on the space station, you'll find the drogue. If all goes well, this will provide an airtight seal between the Soyuz and the ISS. But first, the Soyuz has to catch up to the station. This time, the Soyuz will be docking with the RASFIT module. As they get closer to the station, they'll begin what's called the fly-around, to get the spacecraft lined up with the right docking port. This involves small impulse burns. You can see the white exhaust coming out of the side. Then they do what's called station keeping, which ensures that the two spacecraft can maintain a constant distance between them. Then comes the final approach, with only about 100 meters to go, traveling at only a few centimeters per second. Remember, this is all automated. There's a docking camera here on the Soyuz, and this will line up with the target next to the docking port on the station. When the probe touches the drogue, this is called contact. The Soyuz thrusters are used to help bring it in. Once inside, this is called soft capture. The Soyuz is attached to the ISS, but not completely. The probe will then retract to pull the Soyuz tight against the station. Around the edges of the docking mechanism, there are 8 hooks. These will mechanically lock the spacecraft to the station. This is called hard capture. Then the electrical and data connections are made, which connect the Soyuz to the ISS. The small area between the Soyuz and the ISS is called the vestibule. This needs to be pressurized with air. It usually takes an hour or two to complete all of the checks and ensure that we can safely open both of the docking hatches. Inside the station, there will be at least 3 astronauts or cosmonauts waiting to greet them. From the launch all the way up to this point, it will usually be about 8 to 9 hours. The crew will stay aboard the ISS for about 6 months. During this time, their Soyuz will also stay attached to the station. In case of an emergency, they would use it as a lifeboat to leave the ISS. And of course, if all goes well, it will be their ride home at the end of their mission.